Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on how to name compounds. Just as a refresher, before we can name the compound, we have to first identify what type of compound it is. So if it's an ionic compound, it's going to be a metal or NH4 plus either a nonmetal or a polyatomic ion. If it's an acid, it'll start with H, and molecular compounds will only have nonmetals and metalloids in them. If we have to identify whether something is a metal or a nonmetal, we should be sure to know where to find them on the periodic table. So if I go from B to TS, boron to tennessine, everything, including the line that is to the right of that, is a nonmetal. And therefore, if the first element is a nonmetal, it's going to be a molecular compound. And then everything to the left is a metal. So if the first element is a metal, then that means that it is an ionic compound. All right, this is our checklist here of how do we identify the type of compound. So we go through and we say, okay, does it start with H? The answer is yes, it's an acid. If not, then we go to the next question. Does it start with NH4? The answer is yes, it's ionic. If not, we go to the next question. Does it start with a metal? If it starts with a metal, it is ionic, and if it doesn't start with a metal, then it is molecular. Once we've identified whether it is an acid, ionic, or molecular, then we can use the appropriate rules of naming to name our compound. All right, so for acids, so the rules for naming acids. We identify what is attached to the hydrogen. If there are no oxygens, then it's going to be hydro, and then that anion, an ic acid. The hydro does not represent the hydrogens. The hydro is there to represent the lack of oxygens, which seems counterintuitive, but it is what it is. If there are oxygens, then it's a polyatomic ion, and we name it based on the ending of the polyatomic. So if the polyatomic ion ends in ATE, then I change it to IC and add the word acid. If the polyatomic ion ends in ITE, then I change the ending to OUS, acid. A good way to remember this is I ate something icky. So then if the ATE is I ate something icky, then the ITE is the OUS. For ionic compounds, I check for polyatomic ions. If there's exactly 2 elements, then there are no polyatomics. If there are 3 or more elements, then there is at least 1 polyatomic ion. Polyatomic ions can be found on the back of your periodic table. There's a giant chart of them, so you'll be able to find any polyatomic ion that is in any of the compounds that we look at on that page. Once we've identified whether or not we've got polyatomic ions, we just write the name. We write the cation name, which is just the element, or the only polyatomic ion that will be first will be ammonium, NH4. So that is the only time that you will not have a metal as the first part of an ionic compound. Once we've done the cation, we do the anion. If the anion is just an element, I change the ending to IDE. If it's a polyatomic ion, I don't do anything to it. I leave it just exactly the way that it is. And then lastly, we have molecular compounds. Molecular compounds are pretty straightforward. It's prefix element, IDE. So this is our list of prefixes that you have to know. Whatever the subscript is after that element in the formula, we use the prefix that corresponds to that number. If there's no number there, then that means that there's only one of the element, and I use the prefix mono, but I only use it if I have one of the second element. If I only have one of the first element, then I don't use the mono prefix, I just name it as the element. And then, of course, the ending of the second element is always going to be ending in IDE. So those are our rules in a nutshell. So now let's do some examples. These are the examples that are in the naming compounds practice that we did in class. All right, I start off by identifying the type of compound. Does it start with H? No, so it's not an acid. Does it start with NH4? No. Now I check to see if the first element is going to be a metal or a nonmetal. So I look here at C2P7. So C is carbon. Carbon is on the right-hand side of the periodic table. It's to the right of my metalloids, so that means it's a nonmetal. So my formula here is going to be molecular. So the rules of naming that I use are prefixes. So if I have 2 C's, the prefix for 2 is di, and then C is carbon. and then I look at P, I have 7 Ps. The prefix for 7 is hepta, and the element for P is phosphorus. And then the last thing I have to do is change the second ending to IDE. So this is going to be dicarbon heptaphosphide. If you put phosphoride, that's okay. We're just concentrating right now on making sure that we have the correct ending. Some of the names are a little bit tricky to know where you stop the ending, like is it phosphide or phosphoride? Is it nitrogide or is it nitride? We'll learn those as we go through and do more practice, but right now we're just focusing on the fact that it's the second element, so it needs to have an IDE ending. Okay, let's look at the second one. So I go through my checklist again. Does it start with H? It does not. Does it start with NH4? It does start with NH4. So that means that it is going to be ionic. NH4 is ammonium. And this is also on the back of your periodic table in case you forget. And then NO2 is also on the back where the polyatomic ions are. And the name of this is nitrite. Because it's a polyatomic ion, I'm not going to change the ending. I leave it just the way it is. The only time I change the ending of a polyatomic ion is if it's in an acid. The name of my compound here is going to be ammonium nitrite. All right, let's look at the next one. Here, I have something in parentheses. If you see something in parentheses, that's an automatic ionic compound. But you can still go through your checklist. Does not start with H, so it's not an acid. Does not start with NH4, so I look at the Al. Aluminum is a metal, so this is an ionic compound. There won't be any parentheses in anything that is not ionic. So for ionic compounds, since we're only concerned with the elements in the polyatomic ions and not the subscripts, we don't care how many we have. The only time we care how many we have is if it's a molecular compound. So this 2 on the aluminum doesn't matter. It only matters that the name of this element is aluminum. And then if we look at the second part of this, we're only concerned with what's inside the parentheses. Inside the parentheses, I have CrO4, which is 2 elements, which means it's a polyatomic ion. So if I go to the back of my periodic table, I see that this is going to be chromate. So again, polyatomic ion, don't change the ending. So this is going to be aluminum chromate. All right, let's look at the next one. So here, if we go through our checklist, does it start with H? Yes, it does actually start with H, so that means that this is an acid. So we're going to use our rules for naming acids. If there's no oxygen, it's hydro at the beginning, ic at the end. If there is an oxygen, ATE switches to IC, ITE switches to OUS. So if we look at what's attached here, I have AS, which does not have any oxygens. So AS is just arsenic here. All right, so there's no oxygens. So that means I'm going to use my hydro-ic naming. So I'm going to do hydro in front of this. And at the back, I change the ending to IC, but arsenic already ends in IC, so I don't have to do anything special here. So this is just going to be hydroarsenic acid. This is the only time when the ending doesn't change. It's the only element that ends in IC that is relevant to what we're doing. Again, this hydro is not for the hydrogen, it's because there are no oxygens here. Okay, next up we have Se6Te. So if we look at this, does not start with H, does not start with NH4. We look at Se on the periodic table. Selenium is to the right of my metalloids. It's a nonmetal, which means that this is molecular. So for molecular, I do need to know what the subscripts are because I'm going to be using the prefixes. So I have Se6, so 6 is hexa. So this is going to be hexaselenium. And then the next one that I have is just Te. So because there's no subscript, that indicates that I only have 1. Since it's the second element, I do have to put the prefix for 1, which is mono. So this is tellurium. If this had been the first element, I wouldn't use the mono, but because it's the second element, that's why I put that mono there. And then finally, I changed that ending to IDE. So this is hexa selenium monotelluride. All right, let's keep going. CD3BO32. These are parentheses here, which indicates to me that it's going to be ionic, but let's go through our checklist anyway. Does not start with H, does not start with NH4. CD is to the left of my metalloids. It is a metal. It is a transition metal, actually. So that means that this is going to be ionic. All right, so because it's ionic, I don't care about the subscripts that tell me how many of them I have. So I only care what they are. So CD is cadmium, and then what's inside the parentheses is just BO3. So this is 2 elements. So I'm going to go to my polyatomic ion chart, and I find that the name of this polyatomic ion is borate. It's ionic, so I don't change the ending of my polyatomic ion here. So this is just going to be cadmium borate. Okie dokie. So let's look at this next one. If I go through my checklist, does it start with H? Yes, it does. So this is going to be an acid. So the H doesn't matter here at all because all acids start with H. All I'm concerned with is what is attached to the H. So attached to the H here, I have CrO4. So CrO4 does contain an oxygen. So because it has an oxygen in it, it is going to be a polyatomic ion. So I go to the back of my periodic table to my chart, and I see that CrO4 is chromate. The only time we change the ending of a polyatomic is when it's in an acid. So since we have it in an acid here, I look at my ending, it's ATE. I ate something icky, so I change that to IC, and I add the word acid at the end. So this is chromic acid. The hydro is not here because there are oxygens. Remember, the hydro is not representative of hydrogen because all of the acids start with hydrogen. The only time we use hydro is if what's attached to the hydrogen does not have an oxygen in it. There's an oxygen here, so I don't need the hydro. All right, next up we have NF5. Does not start with H, does not start with NH4. It does have an N, but in order to be considered NH4, it has to have the H4 as well, which it does not. So now I'm just going to look at this element here, N. N is to the right of my metalloids. It's a nonmetal, so that means that this is going to be molecular. So for molecular, I use prefixes. So the first one, I have N. There's no subscript here to tell me what prefix to use, so that means that there's only one. Because this is the first element, I don't put a mono. So this is just going to be nitrogen. The first element does not get a mono. If this had been flipped and it had been F5N, then it would be mono in front of the nitrogen. The second part of this is F5. The prefix for 5 is penta, and my element here is fluorine. So because it's molecular, I have to change the ending of the second element to IDE. So this is going to be pentafluoride. So the name of this is nitrogen pentafluoride. All right, let's keep going. Number 9, go through my checklist. Does it start with H? Yes, it does. That means it is an acid. So I'm only looking at what's attached to the H, not the H itself. There is a ClO here. Since there's an oxygen, that means it's a polyatomic ion. So I go to my chart here, and I see that this is hypochlorite. So I'm going to look at the ending here. I see that it ends in ITE. It's I ate something icky, so that means that it is not IC, it is OUS. So then I add the word acid at the end, and now I get here hypochlorous acid. All right, next up we have Na3ASO4. Go through our checklist. Does not start with H, does not start with NH4. If we look at our element here, Na is sodium. Sodium is on the far left-hand side of the periodic table, so it's a metal, which means that I have an ionic compound. So I only care about what my two parts are here. So Na is sodium, like we just said. And then there's a bunch of stuff attached to the sodium. So again, you can only have 2 parts to every compound. So this is not going to be arsenic oxygen or oxygen arsenic or anything like that. It's going to have one name. Since it's 2 things put together, it's going to be a polyatomic ion that we find on the back of our periodic table. So if I look there, I see that this is going to be arsenate. So the name of my compound here is sodium arsenate. All right, next up we have B4Cl9. Go through our checklist. Does not start with H, does not start with NH4. If we look at boron, boron is the very first of our metalloids. So our metalloids count as being on the non-metal side. So this is molecular. Because it's molecular, we're going to use prefixes. So I look at my 2 elements here. I have 4 of the B's. So the prefix for 4 is tetra. And then B is boron. And then we have Cl9. So the prefix for 9 is nana. And then Cl is chlorine. I'm going to change the ending of this to IDE. And I get tetraboron nana chloride. All right, last one. We go through our checklist. Doesn't start with H, doesn't start with NH4. We look to find it on the periodic table. Ga is just to the left of my metalloids, which means that it's a metal, which means it's ionic, which we also could have determined here because there are parentheses, meaning that there's a polyatomic ion, so it's ionic. But again, the checklist works every time. So we find that Ga is gallium, and then we only care about what's on the inside of the parentheses, not the subscripts on the outside. So we look at OH. This is 2 elements. So we're going to look at the back of our periodic table, and we find that this is hydroxide. So because it is ionic, we do not change any endings here. We leave it just the way it is. And I get gallium hydroxide. So that is, in a nutshell, how to name compounds. This has been another episode of Chemistry with Wikipedia, tutorial edition. I hope you learned something, and until next time, keep on chemin'.